Hello and welcome back. Today we're going to be talking about the side and side angle side triangle congruences. The reason that we use these are to prove triangles using fewer parts than knowing that all parts of the triangle are congruent. So for side, only thing that we need to know to prove that these two triangles are congruent is that three sides of one triangle are congruent to three sides of the other. If we have that, then that means that both triangles are congruent. So we're just going to take a look at our picture here, and based on the picture, we're going to write an if-then statement. This is what we call a proof, a two-column proof. So for side AB, if AB is congruent to DE, if side BC is congruent to side EF, and side AC is congruent to side DF, then triangle ABC is congruent to triangle DEF. Okay, we're going to do an example. This is a sample proof. When you're doing proofs, the first thing that you need to do every single time is to write down every single given statement. So in this example, we have 1, 2, 3 given statements. They've already listed them out for us on the left side, so we're just going to fill in the reasons. So PQ is congruent to ST. That is the first given. QRs is congruent to side RT. That is also given. And R is the midpoint of PS. They also give that to us as well. Okay, so the first thing that you always want to do with proofs is to write down the given statements. The last thing in the proof is what you're trying to prove. So in column 5, we just write down, and this only goes in the statement side, we write down that the triangle PQR is congruent to triangle STR. That's what they have right here. The reason, that's what we have to find out. Okay? Now let's take a look at line number 4. This says that PR is congruent to RS. So in our picture, they're saying that these two segments are congruent to each other. Well, that looks pretty accurate based on the picture. Okay, but how do we actually know that they're congruent? Well, in step 3, it says that R is the midpoint of PS. So if R is the midpoint of something, that means that that entire segment is split into two equal pieces. So PR and RS would be congruent because PS gets split into two equal parts. So this right here comes from the definition of midpoint. One thing that I forgot to mention that we need to do before we even start writing our reasons or our statements is we need to actually go through and mark down what the picture's telling us. So anytime that you see R is the this midpoint at all, okay, that that big long segment is going to be split into two equal parts. So if you see midpoint, go ahead and create the two equal segments. Okay, so we're going to write that down. Create two equal segments. Two equal segments, or you could say congruent. Okay, it's the same thing. PQ is congruent to ST, so that means that these two sides are the same. And then QR is congruent to RT. Okay, so right here in our picture, we have something very similar to what we had up here. So we can say that because we have 3 congruent sides on both triangles, that triangle PQR is congruent to triangle STR. So the reason that this is true is by the side, side, side. Okay, so you could write side, 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 or you could just put SSS. Okay, let's go ahead and flip the page. We're going to talk about side angle side now. For side angle side, if 2 sides and the included angle of one triangle is congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. Remember that we said that included was kind of a fancy word for connected, or it connects. So for side angle side, 2 sides are connected. 2 sides are connected by an angle. So side AB is connected to side BC by angle B. So for our congruency statements, if AB is congruent to DE, okay, that's a side. Now we're going to do the angle. If angle B is congruent to angle E, and if side BC is congruent to side EF, then triangle ABC is congruent to triangle DEF. So let's use this in our next example. This time we've only got 4 different columns, or I'm sorry, not columns. We have 4 different rows. So that means that we're going to have 4 statements, 4 reasons. First thing that we do, okay, step 1, write down the givens. Write down what is given to you. Okay. After we do that, then we're going to label our picture. Okay, so first thing we're going to do, we're just going to go through these first 2 steps. JM is congruent to NL. Okay, that's the first one right here. In the box we put given. And then we have angle JMN is congruent to angle LNM. That's in the second box. That is also given. Okay, box number 3, it says side MN is congruent to side MN. Now, this is a very neat property in mathematics because we know that MN is congruent to MN because it's the exact same thing. So, we're gonna come back to this in just a second. I want to make sure that we label the picture first. So JM and NL both get 1 little hash mark. And then the angle JMN, here's JMN right here, gets 1 hash mark. And angle LNM gets 1 hash mark. And then we'll just go ahead and put 2 down for MN because it's the same thing. So, anytime that you have something similar to this, what we can do that's very special is we can just write down reflexive property. The reflexive property just states that basically side MN is congruent to MN. If you flip this around, it'd just be the same exact thing. So reflexive property for this one. Okay, so now we have a side angle and a side. Triangle JMN is congruent to triangle LNM. We know this is true by side angle side, or the SAS.